Right, so let's do this because I'm recording for Zuri's benefit. Okay, so find the measure of the central angle. So the only thing I thought about with this question, which didn't seem to be a problem for you, is this area the whole blue thing or just this section? And I thought, well, it does. It would make it a completely different question. So hopefully you all went, yeah, it's just the whole area. Okay. So what do we have? This information. It says find the measure of the angle. So we know that theta over 360 multiplied, we're given area, so that's pi times 8 is the r, 8 squared is equal to 67.02. Okay, so then we rearrange. So we multiply through by the 360. So we've got 67.02 multiplied by 360. We then divide by 64 pi. So all divided by 64 pi. And I think you get the answer rounded to 120 degrees. Yeah? Make sense?
No.
Why? That should be absolutely no problem to you. If you've done any of the work that you should have done in that section and any review at all, that should be absolutely fine. If it's not, you've not done the work you need to do. Simple as that. Okay. Find the length of the minor arc. Well, now that the minor arc is just this arc, yeah? So again, it's just this option, but this time it's the fraction we now know is 120 out of 360 degrees of the whole circumference, and the whole circumference is, well, either 2 pi r squared, 2 pi r or pi d. So I used pi d, so d is 16 pi, okay, and we've got that. I've got my answers written out, so we know. So that works out at, well, 16.755 I got, so I rounded that to 16.8 centimeters. All good? So whose account are you looking at now?
No, I'm trying
Is
to
it a good
download
dance?
the extended textbook because
You don't need to at this stage, eh? You've got it. Do you not need this?
No, I do.
Okay.
But I just
So maybe pay attention to this then. So you can answer my questions if I need to. Find the perimeter of the shaded sector. That is as simple as, well, if I know the arc length is 16.8 and then I've got 8 and 8, so plus 16, and you get the answer 32.8 centimeters is the perimeter. Okay, and find the length of the chord. Well, this time the chord is from M to N, yeah? So they tell you that. So that is part of this triangle, right? This triangle has an angle of 120 degrees, not 90. Okay. All right. This length is what I want to find. I know this is 8 and this is 8. All right. So we do actually use right-angled triangles, but we cut it in half. It's an isosceles triangle. That means what I find here, all right, and this angle is then 60 degrees. And what am I going to then use? So I've now got this right-angled triangle where I want to know that this is 8, this is 60. No. Could use special triangles to solve it, but it's just trigonometry, isn't it? So this is going to be sine of 60 equals opposite over hypotenuse. So should I say x over 8? So x is just 8 sine 60. Now, if it was a non-calculator paper, I'd expect you to know what sine of 60 was, which is good. So I could chuck that in, but you don't need to in this case. All right. You can just work out that it ends up being what? 13 point. I think I've got 13.9. All right. because no, sorry, this works out being 6.9. So then I have to double that to find the chord length. So that times 2 gives me the 13.9. Okay, makes sense? I think that was the one not many people got at that stage.
Yeah, I just skipped it.
Yeah.
I had no clue that was true.
Again, that does come up in the exercises that I said make sure you've done before we move on. Are you all ready to move on? Yeah, we're ready to move on. Okay, so don't say you're ready to move on if you haven't covered all these things. There's something to learn for the prep stage. All right, pendulum.
I don't know what that is.
You don't know what pendulum is?
I had to ask the class. I didn't know.
Have you not done pendulums in science? Oh my word.
I like drew it.
Yeah.
And then it will rotate on the point at the top of the
Yeah.
string.
I still
So
don't
it's
know
just-
what that is.
I don't know.
It's like, it's just a thing that moves like that.
Can I look it up? Do I have permission?
Right, I will do something for you. So let's actually do pendulum video so you can see. So these are all pendulums. It's a bit more than that. So all of those are pendulums, individual ones, and what they then do is you push them and they just swing backwards and forwards. Now, the thing that's interesting about this is if you make them different lengths, they swing at different frequencies, and then you get this pattern. And then what's quite interesting about this is it then goes through all these weird different patterns, and then it repeats again and again, which is amazing, really. All right, all because of the lengths. But that on its own, this front one, this is what a pendulum does, swings backwards and forwards. All right. So in the olden days, you'd have a grandfather clock is run by a pendulum swinging backwards and forwards. You're all transfixed by that now. So.
Yeah, we were like for hours.
Well, actually, that is like there's have you seen actually those desk toys that you swing the ball and it hits the other one?
That's
And
why I can't have one.
yeah.
I was
Okay,
waiting for
so
it to go
I
back
got
to
this
that.
wrong due to lack
Not
of understanding of the question.
Well, I will also come back to the fact that this is a question from the book.
Yeah, but I wasn't here on Friday. I didn't even know.
Oh my word! What? No rubbish.
No, I wasn't.
Right. So a pendulum. So the pendulum is basically a length with a weight on the end. So a pendulum, right, has a total length of 30 centimeters, and then it says, if the distance traveled it moved a total of 45 degrees. So that means that this has been.
I wanted to learn somewhere where I could go anywhere else in the world. I'm still able to treat other Korean people in New York City. I love my job.
We're the #1 provider of doctors in the first-year U.S. residencies. St. George's University School of Medicine. Are you in?
Draw a straight line through and then do a triangle. This is an arc because we're doing lengths of arcs.
Quality writing makes your schoolwork better. Meet Grammarly, the digital writing assistant that helps students create effective writing that delivers results. Getting in-depth writing feedback couldn't be easier. Suggestions are provided in real time to help you write clear and mistake-free sentences. These thoughtful suggestions help you tighten up important papers, group assignments, and even emails to your peers and professors. And Grammarly can check your text against billions of web pages to make sure your writing is original. You know that email you're nervous about? Grammarly can tell you if your tone sounds just right. Quality writing can make all the difference, whether you're at your desk or on the go.
The angle is now the unknown, but we know the arc length is 10 centimeters.
Customize your writing feedback based on what you're trying to do. Set your goals. When you're writing an essay for class or an email to a professor, to get tailored suggestions based on the context of your work. Write confidently knowing that Grammarly is there to help you share your perspective, inside the classroom and out. Download today at Grammarly.com.
And you get the angle is 19.1 degrees. Okay?
Take your seats.
All good?
Take your seats, please.
See, you're not making any notes, Sam. Might be good to make some notes. Get a pen out, you know?
My lecture will be about 40 minutes. And after that, I will give anyone the opportunity to ask me questions for about 15 or 20 minutes. So the whole thing will be 1 hour. And it is after that hour
I am
that we
recording.
will
Just
do L
this one
over
was
G.
generally not too bad.
You already
but
know
again,
what L is.
it's a
If you
cut.
don't know what pi is, you might as well
Right.
leave right now.
This, by the way, is where
And G
I think I mentioned in one
is what we
person
call
on one of their
the
questions,
gravitational
this is where you
acceleration,
have a formula
which is
which
approximately
you
the
apply
same
with little
everywhere on
understanding of
Earth,
what the
but
formula
it is
actually
very
is.
close
So
in
you've
Boston
seen
to
that the surface area of a
9.80
cone, right?
meters
So
per
surface
second
area of a cone, what
second.
is it? Pi
And you will say, well,
rs
that's weird,
plus
meters per second per second.
pi r
What
squared.
that means
And if
is
you just
that
have
if you
the
have an
formula,
object and you drop it
but
from
you
a
don't
very
really
large
understand what it's
altitude,
about,
very
where it
high,
comes from,
few hundred
you just plug it into
meters
that.
high, and I dropped it
But
to 0 speed,
this
after
is
1
the
second, it will have a speed
curved
of
bit. This is
9.8 meters
the
per second.
circle
But
that
after
would go
another
on the
second,
bottom or
it
the
will
top.
add to that
But as it's a
9.8 meters per second, so
cut,
it's twice
there is
that.
no
And after
this
3
bit.
seconds, it's 3 seconds. So
Right.
now you understand why
And
it
that
is
was
meters per
this
second.
question. So simple
per second.
as calculate the area of
So
the paper
that's the
used to
meaning
make
of
cut.
G.
Pi times 6 times 9.
There's something weird
Yeah.
about this equation. Something that must go against your
Which turns
intuition.
out to be?
And you shouldn't feel bad because it also goes against my intuition.
Just where am I?
So we have the pendulum, and suppose
169.
I bring the pendulum all the way out here. We call that the
Right.
amplitude of the
So
pendulum. and we
that
let it
backs
swing
me
back
up
and
again
forth.
in the if you are just given a
There's
list
a
of
certain
formulas, but
period.
you've never actually
But now
taken the time
we
to
bring it
work
out
on
only
them,
this far. It doesn't
figure
have
out
to
what they're
travel
about,
very
when
much
they're
at all.
applied, how they're applied,
Doesn't that make a
kind of
difference
stuff.
in the
You just
period?
make those mistakes.
The
So
equation
would
says
you agree
No,
that
it doesn't. Because if it
you are
did make a
lacking
difference, there would
knowledge
be
and
in that
understanding
equation
criterion A
the amplitude,
if
which
you
is
just
not.
plow it all into the
And
same
I'm going
formula?
to demonstrate that to you,
Yeah,
that it
so
is
that's
quite
where you
remarkable
drop.
that
Even though
indeed
you've kind
that
of done
period
lots
is
of correct
independent
stuff,
of amplitude if you don't
it's
go
not
to
really
extreme
knowledge
values
and
of the
understanding.
amplitude.
All right.
There's something else in
This
here
time,
which is even more
solid cone.
non-intuitive.
Okay.
And that is
So I always like to do my little
Doesn't it matter?
sketches.
whether the bulb, we call
So a
this the
solid
bulb, whether it is
cone
1
has a
kilogram
surface
or
area
500
of
kilograms,
125.7.
you would think, wow, that must be a
Base
difference, must make a difference
radius
in the period.
is 4
But the
centimeters.
equation says
Find the curved
sorry,
surface area of the cone.
it doesn't. And I'm going to demonstrate that to you too.
So we know that the whole
have
surface
here
area
By the way, if you ever
this
want
time
to test
is
this
pi
pendulum,
rs
this
plus
equation for
pi r
yourself,
squared,
put in L
and
equals
all
1
of
meter
that
and use this number, you will get a period of
equals
2.0 seconds. It's very easy to do at
125.
home. You make
So
one meter, you put
the
an apple at
R's
the bottom,
get replaced
and you swing
with
it. No, the 1 meter has to be accurate.
4.
You see that it's going to be
4
2.0
there.
seconds.
4 squared. Okay.
Our pendulum that we
This
have
bit
here
can just be subtracted.
is really
so pi,
the mother
4
of all
pi
pendulums.
times s is equal to
Look at it.
125.7 subtract
15.5
16
kilograms
pi. You're okay with
and the
making
length
that step there? What
of
is it?
this pendulum
All right. So
is
I think you then
5.21
end up
meters.
with just
However,
that bit, which is
You
the
must understand
curved surface area,
it is very
and you end
difficult
up with it equaling
measure that
what
to
is it,
very high accuracy.
75.43.
And so there is an uncertainty in the measurement of the length that we have to
So you know
be
that
honest
that
about
is
because
so that's
we are
centimeters, square
physicists
centimeters.
after
So
all.
that's the curved surface
And the
area.
uncertainty we
And then
estimate
find
is
the
about
slant
5
height.
centimeters.
Well, then it's
we could be off
75.43
by 5
divided
centimeters.
by
That means
4 pi tells
that
you
is
s,
1%,
and you
5
work out
centimeters
that
is
s is
1%
almost
out of
exactly
521.
6.
But since
6.00
L only shows up as
something.
the square root, it means the uncertainty
And
in the
then
time that we
find the
predict is
vertical
only
height
half a
of the
percent.
cone.
And if you don't see the reason
Well,
why the
what do we
1%
use
becomes
then?
half a percent,
So the
that's okay,
vertical
then just
height
forget
of the
about it.
cone,
You
sorry,
take my
I've
word
gone
for it.
up the diagram, is this.
So
We
now,
now know that that's
I can
4,
make a
the
prediction.
slant height is 6.
so I predict,
So we've actually got
using this equation,
a right
that's all
angle
I do.
triangle,
I put
4,
in
6, and the
5.21.
height is what I want to know.
I put in
So what are we gonna use this
9.80,
time?
I multiply by 2 pi,
Now it is
and I make the
Pythagoras'
prediction
theorem. So
that
you
the
end up
period
with
of that
what,
pendulum
6 squared
is
subtract 4
4.58.
squared, square rooted, and you get the
plus
answer
or minus
square root of 20 or
0.02
4.47.
Why the plus or minus 0.02? Well, that is the 0.5% uncertainty due to the square root of L. And you can immediately see that 2 is about 0.5% of 4 plus 58. So my prediction can be no better than that.
All good? Any questions on that?
Now comes the problem.
No? Right,
I have to
no,
measure
Sam?
the period to convince you that it is independent of amplitude
I can't believe
and to
I have to keep
convince you that
telling
it is
you.
independent of mass. So the biggest problem now is Walter Lewis.
Right.
What is it? Well,
yeah, all right.
know,
Yeah, okay,
but
good
I
one.
have a
Yeah.
feeling
No, I was.
That's
I was
even on
doing
video.
that.
if
That's
you
actually,
Right.
be kind to me for a change,
A tetrahedron
let
is
us
a 3D
assume that my
solid,
reaction time
and it even
at
says
875
with all
is
4
now
faces
2
equilateral
tensors.
triangles.
So if you
Find
can
the
live with
surface
that,
area. So we basically
then
just
every
have to do
measurement that I make,
4 lots
no
of
matter how long it is,
an equilateral
it is
triangle.
uncertain.
Each triangle
2/10 of a second.
is 7,
Do
7,
not confuse
7.
that
So
with
we've
that
got
0.02.
4 times
That has to do with the
a
length.
half times the base times the height.
So, I'm going
So that's
to
4
first
times
make
1/2. The base is 3.5. The
measurement
height,
at 5
don't know.
degrees,
So we do have to do a little bit of
and then
work.
at 10 degrees.
But we've got
amplitude.
7,
And I'm going
3.5
to measure 10
x
periods,
or
not
height.
one. Some
So
of you
this
may
is
think, well,
7
that's a waste
squared,
of time.
subtract
10 periods if you can
3.5
get away
squared,
with one.
square
You will very
rooted
quickly see
equals,
why
and
it
I
is
do
10.
get the answer,
You will see that.
6.06.
Is then
So
going to
that
be
goes up
some
here,
number
6.06.
plus or minus
And I
my
get
own
the surface area
inability,
is then
which is my 0.2 seconds reaction time. I can
84.87
change that.
square
And
centimeters.
so then I do it at 10 degrees,
Okay.
and then we get again 10 T.
Again, nothing too
We get a number,
dramatic or
and then we get
long-winded or
again
yeah.
plus or minus
Shouldn't-
0.2 seconds.
Yeah.
And I'm going
I
to
will make the
demonstrate
point
to you
again
that
unless you're
within
not
the
properly
uncertainty
prepared.
of the measurements,
So
that I get the same numbers in all 3
if you
cases.
didn't utilise
Within the
all the
uncertainty.
time,
Yeah, they are.
So, if you're ready for that, you see here
right?
the timer.
You're on video, by the way,
All
so
of you
they
can
will
see.
know if they watch the video.
And
They don't watch the video.
Right, this one,
And I have
guys,
2
this
marks
one
on the
you
floor
are going to
here.
kick yourself
If I
out.
hold the bob here, then it is 5 degrees. This is 5 degrees. And when I hold the bob here, it is 10 degrees.
I didn't get to it, so
I did this yesterday, and I'm gonna
Right,
And then you let it swing 10 times, and then when it comes to a stop, you stop it.
right, guys. So
And
the
it would
important
help
thing
me
here
if you
is
count
that it
how many
says they
oscillations we
are
have made.
mathematically
Because
similar.
then I don't have to look
What
at
that
it.
means is
All I have to do is when I come
if
close to 10,
lengths
I have to watch
are
for the moment of
multiplied
stopping
by
and
something,
then I will end
areas
it.
are multiplied
So,
by the same
we'll
thing
do this first at
squared,
5 degrees.
and volumes are multiplied by the same thing cubed.
So I did not.
So what was
So,
the actual answer?
4 to
I'm going to
6,
start it when it comes
you
here.
multiply by 1.5. Therefore, the areas,
Okay.
so if the
you
area
count.
is 64, we multiply by 1.5 squared, and we get the answer 144. Did you show any work?
Yeah, I did actually kind
You're
of.
doing
like,
very
to
well.
extent, I did.
Square centimeter.
I didn't do it
You're
that
going
way.
to pass
but I
this.
did-
So,
Climbing is
we're
tricky.
looking at,
Because
here's a
when you
ring,
look at the pendulum,
right?
and when you
Here's
see
the
it stand
ball,
still,
right?
that
The ball is
really well
basically
defined,
only just
plus
going
or
to fit
minus
through the
0.1
ring,
second.
but it
When
doesn't
you're
work
swinging
to just
yourself,
say
however,
the ball
then
probably
you can
won't
only
fit through
do
the
it
ring very
by
easily. Right?
sensing
You
the
have
moment
to give
that you
right?
think you stand still.
justification
That's what I
for
will
that.
do.
So how are we going to justify
And then
that?
you will do the counting.
With numbers, all right? We need to
And this is very
compare
unpleasant.
the diameter of the ring with the
It is.
diameter of the ball, right? So, the diameter of the ring, we're told that the circumference of the
Oh,
ring
there's something else I
is
haven't told you.
95 centimeters. So
If
the
you're a good
diameter,
physicist, you will say,
well,
if you're going to sit on
circumference
that
is
ball,
just
then
pi d.
effectively
So
you
pi
bring the
d
mass
is equal to
of the bob
95.
up,
So d
and so
is
the length of the
95
pendulum
divided by
will
pi.
shorten,
All right?
and so you get a shorter
Which
period.
works out to be
And I know that too.
30.24 centimeters.
Therefore,
Be careful of your
I will
rounding.
have to stretch my body
Right? The
so
ball,
that when it is here, that it is
okay,
almost completely
you are
parallel
told
to the floor.
that the
If I don't
surface
do
area
that,
of the
I will
ball
not
is
be able to convince you
2,830
that
square
the period
centimeters.
is
So the
independent
formula
of
for
the
the
mass.
surface area of the
And that
ball
makes it
is
very difficult.
4 pi r squared equals 2830. So r squared is
So I will
2830
start it
divided by 4 pi.
At some moment,
So
you
it
will
turns
see
out
when,
that
and then you'll do
r
the counting.
is 15 point, and I did write it all the way down to that centimetres, which makes d 30.014. So the final thing is to say, look at those two numbers.
Are you ready?
What is the clearance of the ball?
Wait, it's negative.
Yeah!
No, the ball is just point one.
You count!
Wait, which one the hoop wants to go?
One nine.
Oh, I thought that was the ball. Sorry, yeah.
The ball's not like.
So 30.24
This happens
subtracts the
sometimes.
30.014. What do you get? You tell me.
Millimeters. Decimeters.
And in fact, nobody knows why.
Okay.
Have to start all over.
Go on then. See, I know you're telling him number and you're not even bothering yourself.
Exactly.
I did not stop it, I really didn't.
It's.
Oh, it's still counting?
226.
Right, centimeters, or
Okay, I have enough energy to give it one more attempt, but not to give it two more attempts.
22.6 millimeters.
2.3
You ready? Okay.
millimeters.
Oh.
All right,
Oh, yeah.
if you need to. But we can then see the ball itself. If I say 2.3, it's got barely 1 millimeter round,
How do they use their feet?
all right, to get through that hoop. If it was to go through first.
this
Now,
really
obviously, what would
hurts.
happen is they kick it, hit the hoop, and bounce and go, you know. But that is why this game is won with that, you know.
Can't you count a little
Like in
faster?
Hogwarts, you had to catch the little gold thing because it was harder to catch it. But if you did that and got it, it was all over. Yeah, this is the same thing. If you can get the ball through that hoop, the game is done because that's such a difficult task. Plus, you've got the other team trying to stop you doing it. All right, so you kind of make your decision whether you play the game normally or you try and go for that. It's, you know? Okay. Yeah. Exactly. All right. But what is important here is the word justify. Without the numbers, there's no justification. You can't just say, although you've got the right idea to put forward, the ball is only just big enough.